Hello and welcome to this repair tutorial, and this overview tutorial also covers a modification for this particular amplifier. So the unit that we're looking at today is the Quad 405, and it is a power amplifier, and it would normally be used with, for example, the Model 33 control unit, but that is not covered in this overview or repair video. So in terms of background for Quad, the company itself started back in 1936 by a gentleman called Peter Walker. And when you think about the time back then, you know, really this was revolutionary. And he was actually making amplifiers under the brand name of the Acoustical Manufacturing Company. And this unit that you see here dates back to 1976 approximately, and its serial number is 3516. So in terms of specifications, the Quad 405, and this is the Mark 1 as I said, not the version 2, is a Class A amplifier, and it will deliver power output RMS of 100 watts into 8 ohms. Frequency response is 20 Hz to 20 kHz, and total harmonic distortion measured at 10 kHz would be 0.05%. On some of the other frequency ranges this would increase to 0.01%, but you know, excellent when you think about the time when this unit was designed. And then for input 0.45 volts RMS, and that would deliver 100 watts. And then for dimensions, you're looking at a height of the amplifier of 115 millimeters by a width of 340.5 millimeters, and then for depth 195 millimeters. And it is a heavy amplifier. It does have a substantial transformer inside of there, and also metal construction overall, and it's coming at approximately 9 kilograms. Now when the amplifier came into the workshop, the first thing or what was being advised was that the unit wouldn't power up or effectively just stay on. And what I'm showing in the video is the input power protection fuse, and that should be rated at T2.5 amps if it's on the UK mains. When I actually looked at the fuse, it was blackened, so that would tend to indicate that excess current had been drawn. But when I inspected the end tip, where you will find the rating of the fuse and the fuse type, it was only rated at 300 milliamps, which was a little bit strange. So fuse replaced with the correct type, but before it was powered up via the dim bulb tester, the first thing was to just make a number of measurements. And commonly for any engineer who works on amplifiers, the first thing that you will do is head off towards the output section of the amp. So a quick check on the output transistors, no short circuits, anything found, and then a quick check also on the input side of the for the transformer, all good, and then also on the secondary as well. So when the amplifier was then powered up by the dim bulb tester, it powered up perfectly. There was no issue or any other faults with the amplifier. And a quick test on the DC offset came in at just under 3 millivolts for the left channel and just on 3 millivolts for the right channel. And that was excellent. So next level of work to sort of be done was, of course, depower the amplifier. But in terms of construction, it's very, very easy to work on this amp. It would have been hand built at that time. And you can remove the side plates and get full access to the solder sides of both the left and the right channel output modules. And what I'm doing there is I'm just doing a visual inspection, checking those solder joints, and again, excellent, no issue there. And then the next thing to do was just to make a number of tests. So what I'm focusing on is the large smoothing capacitors that you see in the video, and just to check these then with an ESR meter, and they were well within specification, almost bang on, you know, to 10,000 microfarads. And then also for the ESR, it was virtually zero, so 0.01 or less, which is fantastic, and there was no visual sign of deterioration. And then also to make measurements on the other electrolytic capacitors on both of the boards, and all within specification, so all very, very good. So once that had been done, the next thing then to sort of concentrate on was what was the additional work required for the amplifier. And I'll get into the area of the circuit and some of the terminology which Quad used when this amplifier was released a little bit later. So the customer, Dave Turner, for people who may of course not know who this gentleman is, he's actually a mastering and vinyl cutting engineer. I've got to know Dave, you know, over a number of years, and really his talent in his work. You know, if you Google Dave Turner, you know, you kind of realise that, yeah, what an incredible man. So, you know, to sort of receive this amplifier from Dave and really for him to entrust me to carry out the modifications and the work, you know, it always is meaningful to myself. So what he was asking was the original speaker terminals for the Quad, they're a plunge type. So when you press in the push buttons on the speaker terminals, you can then just insert the speaker wire and then just let them go and they will then grip. And what he was asking, Gary, you know, can you do a modification here then just to retrofit and make them adaptable then for the typical 4mm jack plugs or banana plugs? Yeah, no problem. So what I was able to source were gold plated speaker terminals, and they fit directly into the existing hole. So these are 10mm overall diameter for the speaker terminals. It's a little bit tricky to sort of get into there. You know, you've got to get access, you know, to first of all remove the original ones, and then with the, you know, I wasn't looking then to do any wiring modifications or anything else. I could then fit the new speaker terminals into there, and I'm showing that in the video both before and after. With the gold plated speaker terminals, they also have the ability, if in the future you can use, as I say, the banana type 4mm jack plugs, or you can go back to conventional wires if you wish then. But the way in which I've done the orientation then is to ensure that you know, you wouldn't be able to, shall we say, incorrectly wire up the speakers to the amplifier. So once that was done, you know, yes, of course, full functional test, you know, under load, and the amplifier, you know, performed flawlessly. So what I want to sort of speak about now is to sort of get into a little bit more of what this amplifier is about, and, you know, sort of, you know, I'd say more detail. So when this amplifier came to market, what Quad were publishing was something which they call a current dumping amplifier, and back then it actually received the Queen's Award for Technology Innovation, and that I don't think that's actually been given to any other audio manufacturer ever since. So that was a remarkable achievement. And then what I'm showing here, and this is from some of the service data which is available, we're just showing a simplified schematic, and what it shows is the Class A amplifier, and then it also is showing them what they refer to then as the current dumpers and also the bridge components. So when it's connected up, what the amplifier is doing here is, and remember that this current dumping output circuit is a terminology which Quad used to market their amplifiers, but they would also claim then to have invented, you know, this technology and published a paper at around the time. What they were stating was that it actually eliminated many of the problems which typically you saw with transistor amplifiers. And what do we sort of mean when we say that? Well, I've put this into the overview description here. So if you are running or designing an amplifier that is not in Class A mode, and maybe you go to Class B or more commonly Class AB mode, because you have the output transistors which are really receiving the positive and negative audio signal coming through, what you want to do is you want to eliminate any what we call crossover distortion between the transistors conducting on and then conducting off. With a Class A amplifier, effectively it's drawing maximum current all the time, and you don't have the issue because you don't have to have this crossover distortion. So again, you know, Quad was claiming at that point you didn't have any issues with that. And as with all amplifiers, typically if you're running in Class B or Class AB mode, often, and you've seen this in some of the other repair tutorials, you have to make adjustments to set the bias current. For this amplifier there is no adjustment, and it also eliminates the need for thermal tracking. And commonly with all amplifier designs, you have to do quite a lot during the design phase for the matching of transistors. And you may also have seen this in some of the other repair tutorials. Often on some amplifiers, even the main output transistors, which handle the current or the higher current then through to the speakers, they have to be to a specific match type. And if you try and substitute them, often you can find during test phase that either they run hotter because of the frequency range, or in some cases they become unstable. So Quad were claiming that all of these issues were completely eliminated then. So how does this circuit actually operate? Well, what you have is fundamentally you have two amplifiers. So the first one is that you have really what is a low powered or high quality amplifier, and you can see that there, which is the class A output, and then that is fundamentally controlling the speakers. And then you have the current dumping circuit, which is handling the heavier current through, and then you have an error detection, providing that the current output stage is providing the required current, then there would be no sort of automatic adjustment then. But if for whatever reason that is not happening, then the class A output side of the amplifier then will effectively compensate for that. And really this was a unique design at the time. And then the next part, and you can see this in the video, is I'm showing you really the full schematic for the channel. And it's interesting to see the design, and then also as well remember that there's two halves to this. So you have effectively the left channel and then the right channel, and then the power supply then is common to both. So you have the large power transformer multi-tapped, as you see here on the right hand side, coming in via the necessary fuse protection that we mentioned previously. And then I also show in the video the bridge rectifier, and then this is bolted then to the case. What this is providing then is typically plus or minus 50 volts, and then you see the large smoothing capacitors. And then what they've also done is they just take the positive supply off that, and then via a drop-in resistor that provides the LED indication on the front panel of the amp. And then you have the protection fuses, you can see, for the positive and then the negative side. And then in terms of input, and if people sort of search for Quad 405 input leads, you can see that the input on the amplifier uses a 4-pin DIN type plug. More commonly you tended to see 5-pin, but you can still source 4-pin. And then you have a ground connection, and then you'll have the right channel coming in and then the left channel. And then what it then feeds via a filter network is it goes to IC1, and IC1 is an LM301A, and this can be sourced now. So it's a single what we call operational amplifier. And again, you may ask the question, why did companies select to use these types of operational amplifiers, and why do they continue to do it even in the most modern designs? And there were a number of other companies around this time period which were using these operational amplifiers in their design. And the reason for that is, if you pull down the data sheet, for example, for the 301A, you'll see the internal circuit diagram for that integrated circuit, and there's quite a lot in there. So if you wanted to do that discreetly, of course you can do that, but that would require additional components onto the board, making the design, I would say, more expensive. But that's really not what drives this, because it's a manufactured package with all of the components mounted onto or etched onto a substrate. What you get is extremely good thermal compensation with the integrated circuit, and also as well they can be manufactured to an extremely high tolerance. So in terms of design, not only have you got excellent stability, but also the designer as well really has closer tolerances then to be working with, and particularly with operational amplifiers. If you didn't connect the gain feedback from the output then back to input, depending on whichever input, if it's the inverting or non-inverting type, it would have infinite gain. So what an engineer is able to do is to be very, very precise on that feedback network, so they can control what will be the gain of the operational amplifier. And it was quite unique, you know, when you sort of think back, you know, to 1976, or anybody who lived in the UK, you will remember 1976. You know, I was probably about 7 or 8 at the time, as being the hottest summer on record. You know, so that to me is quite a while ago, and seeing that LM301A inside of the quad amplifier, you know, the engineers were pushing, you know, the realms of design. You know, they were taking, I would say, bold steps. So they were using, you know, some of the latest technology, but also as well, what quad were not doing is just following the normal pathway of maybe all of the other audio manufacturers. They were coming to market and saying, look, we're going to rethink, you know, high quality power amplification here, and we're going to come with this current dumping type design. And as I said earlier, you know, it received a industry award, or the Queen's Award for innovation in technology. And then what I also want to sort of bring to your attention as well is that Quad also produced electrostatic speakers. Now, this amplifier in itself doesn't have like a conventional speaker protection circuit. Okay, so when the amplifier was purchased, what you would have received is 2 resistors. You would have received 2 1.8K resistors, and if you look in the service data, these resistors just plug into the board, and I also show it on the video. You can see on this amplifier they were never installed, but for some amplifiers they were. So the reason why I mention the speaker protection side is, if you were using the quad electrostatic speakers connected to the amplifier, then the guideline would be that you would install the 1.8K resistors, which are kind of acting like a protection for the output stage. So once the resistors are in circuit, you can see here, and you would do this then for the left or for the right channel. And what it's basically doing is it's limiting the maximum RMS voltage at 100 watts to 20 volts. So if you had to look at that as a peak to peak voltage, then it's going to be approximately 28 volts peak to peak. And then again, for non-electrostatic speakers, nothing prevented you, if you wanted to have some form of speaker protection by this limitation on the maximum drive, then you could install these resistors. But I think it's sort of important just to sort of, you know, make the note and then to make the point here. So really that kind of brings us to the end of this overview, repair, and also modification. This does happen from time to time, and in this case what I've done is, you know, when the amplifier gets returned back to Dave Turner, I've also included the original spring type speaker terminals, so it sort of just keeps the originality of it as well. For me, this is probably maybe only the second one which has come into the workshop. I know you know, the quad range, and there's also sort of circuit boards which are effectively the same design, but, you know, modern, where people can build these amplifiers. But I think to come across a Mark 1 in this level of condition is quite remarkable, really. You know, when I looked at the overall case, everything, you know, even the same original rubber feet on there, it's really been kept, you know, in remarkable condition as well. And now, just before I sort of close out, probably another point which is important is that sometimes during the tutorials, what I talk about is really, you know, an amplifier in its original condition. And I just sort of want to sort of clarify what I mean by that. I understand, you know, that any piece of electronic equipment will fail at some point. It's not if, it's only the when, which is the part that you don't know. Now, if I receive an amplifier in its original condition, that to me as an engineer is something very good. And the reason why it's very good is it means that the amplifier has not been worked on previously, so it's as it left the factory. Also as well, no modifications have been made. And when you look at these classic amplifiers like the Quad, for any owner of that amplifier, they will normally say, I want to keep it as original as possible. Now, I could have just fundamentally block changed out all of the capacitors and everything else, and people may well listen and say, well, you know, this is an old amplifier, why did you not do that? You know, if I'm making the measurements of the electrolytics and they are within specification, there's no physical deterioration and the ESR is very, very low, it's really keeping that originality of the amplifier. So, you know, often the components that we use at that time, you know, deliver a type of distinctive sound, you know. And don't get me wrong, if there were any of those electrolytics were out of tolerance, absolutely I would have replaced them then with the modern day high quality equivalents then. But I think here this repair and modification really has been a process of keeping as much as possible of the original as it is, and then just with the slight modification here, just to add these gold-plated speaker terminals, which I think also from a safety point of view, you know, you don't want to accidentally short the outputs of any amplifier. You know, it gives that added sort of confidence then that you can use the jack plugs. So that really brings us to the end of the tutorial. So as I always say, you know, it's a real pleasure being able to share, you know, the knowledge, and also for you, you know, as the listeners, for stopping by and just taking some time out of your day, you know, to listen. And if you have any questions, by all means email audio amplifier servicing at aol.com, and I'll be more than happy to come back to you and then to provide any guidance or support when you repair an amplifier yourselves. So thank you very much. Until the next time, thank you. Goodbye.